This is 7.2 now, question number 9. Now here the question is, find out the coordinates of the points which divide the line segment minus 2, 2 and 2, 8 into 4 equal parts. Okay, 4 equal parts. So here I have divided this into 4 parts and 4 equal parts. Okay, 1, 2, 3, 4. Okay, and the question is, find out each of these points. Now this is a very easy question. What we can do is we can find out the coordinate of Q first, because you realize that Q is actually the midpoint of A and B. Q is the midpoint of AB. So here we are using the midpoint formula. X is equal to x1 plus x2 upon 2 and y is y1 plus y2 upon 2. Okay, so x will be, if you take the value of x1, what is that? That is going to be minus 2 plus 2 upon 2. Right? So minus 2 plus 2, you are going to get 0. So 0 upon 2 is 0. So here we get the value of x as 0. And what is the value of y here? 2 plus 8, y1 plus y2 upon 2, no? So 2 plus 8 upon 2, 10 by 2, so we get 5. So coordinates of Q, you will get 0, 5. To find the other coordinates, you can just use midpoint formula again. So P, if you want to find out P will be the midpoint of A and Q, right? It will be the midpoint of AQ, and R will be the midpoint of Q and B. So I'm going to use midpoint formula. So first I'm finding out the value of P. How do I find P? Take these two and find out their midpoint. So minus 2 plus 0 upon 2. And what are the coordinates of y? You will get 2 plus 5 upon 2. So here we get minus 2 upon 2 minus 1. And this will be 7 by 2. So coordinates of P is minus 1 and 7 by 2. Similarly, we can find out the coordinates of R. R can be 0 plus 2 upon 2 and 5 plus 8 by 2. So 0 plus 2 by 2 will become 2 by 2, that's 1. And the coordinates of y will become 5 plus 8 upon 2, that's 13 by 2. So coordinate of R we will get 1, 13 by 2, right? So we've got all the 3 points P, Q and R, and we are using midpoint formula in all the 3 cases. Then the last question of the exercise, question number 10. Okay, this is a question about rhombus, and you know that a rhombus is a figure in which all sides are equal. They have given the vertices of the sides, vertices of the rhombus. So coordinates are given in order, that's important. Okay, so when you name this, it should be ABCD or ABCD, clockwise or anti-clockwise. Don't change that. So here we have named it anti-clockwise, A, B, C and D. So what are the coordinates of A given? 3, 0, B is given 4, 5, C is given 1, 4, D is given minus 2, minus 1, right? Question is, find the area of this. Now you remember this formula. Area of a rhombus can be found by using the formula half diagonal 1 into diagonal 2, or half AC into BD. And how do you find the length of the diagonals? We will use the distance formula which we did in the first exercise. So first I am going to find out the distance between A and C by using distance formula. This is the distance formula if you have forgotten. x2 minus x1 whole square plus y2 minus y1 whole square, and take the square root of that. Okay, so x2 minus x1 whole square, I am applying first here the distance formula. So minus 1 minus 3 whole square, 4 minus 0 whole square. Okay, the order doesn't matter. It could have been the other way around. This can be x1 y1 or this can be x1 y1. That doesn't matter. So I am applying this. You will get minus 4 square, that is 16, and 4 square 16, 32 when you add this. Now 32 can be written as 4 root 2, because 32 when I factorize, I can make into groups, right? You remember that 32. I can factorize this, prime factorization, and this forms a group. So 2 and 2, 4 comes outside and 2 is left. So 4 root 2 is the distance. Same way I can find out the distance from B to D. Okay, how to find the distance from B to D? Again distance formula, x2 minus x1 whole square. So 4 minus 2, minus of minus 2, so that is why we have got plus 2 here, plus y2 minus y1, so 5 minus of minus 1, that will become plus 1. So 6 square and 6 square will become 36 plus 36, 72, and root 72 by prime factorization, if I calculate, that will come 6 root 2. Okay, and once we get the length of the two diagonals AC and BD, we will use the formula area of the rhombus, half product of diagonals. We have got the length of the two diagonals. We will multiply 6 and 4, 24, and root 2 into root 2 will become 2. So this 2 and this 2 gets cancelled, and we get our final answer 24 square units.